What is resistance? And types of electrical resistance, in simple words.
Resistors are one of the most important and basic electronic components and play an important role in electronic circuits. These parts have different types, from very small resistors or chip resistors to resistors wrapped around a non-conductive core. The main function of resistance in an electrical or electronic circuit is to prevent the flow of current or to regulate and determine the flow of electrons using conductive materials inside it. Resistors can be used in combination in series and parallel structures. In this way, we will have a resistance network that can be used to create a voltage drop, divide the voltage or limit the current in the circuit. Resistors are passive parts. That is, they consume energy and are not able to produce it. Therefore, resistors are not power supplies or signal amplifiers. But they reduce or attenuate the voltage or current. When resistance prevents the flow of electrons, energy is lost as heat. For the current to pass through the resistance, it is connected to the electric potential difference. The energy lost in the resistor is related to the potential difference between its two ends. When this potential is applied in DC circuits, as the current passes through the resistor, a potential drop occurs at both ends of the resistor.
Most resistors are linear components, and when an electric current passes through them, a voltage drop occurs. This voltage drop is because resistors obey Ohm's law. Different amounts of resistance produce different amounts of current or voltage. It is important to control or reduce voltage and current in electronic circuits. In this way, it is possible to convert voltage into current, and current into voltage. There are hundreds of different types of resistors. These resistors are suitable for various applications due to their special characteristics and required accuracy. Some of the specific characteristics of resistors are temperature coefficient, voltage coefficient, noise, frequency response, power as well as temperature rating, physical size and reliability. There are different types of resistors based on the raw materials used and their manufacturing and application processes.
Types of electrical resistances in terms of application. Fixed resistance. It is called a resistance whose value is always constant and is the same as the nominal value written on the resistance. Environmental factors and different voltages do not affect the value of this resistance. Variable resistor. This resistor is used to adjust the value of the resistance in order to control the voltage or current or a part of it. These types of resistors do not have a fixed value in the circuit. Fixed resistors have only one value. For example, 100 ohms. In all electrical and electronic circuit diagrams and schematics, the most common symbol used for constant resistance is a zigzag line with the resistance value in ohms, omega, above it. The resistance value can be from less than 1 ohm to several million ohms. Variable resistors, potentiometers, can have infinite resistance values between 0 and their maximum value. Types of fixed resistance in terms of construction.
types of fixed resistance can be divided into 4 categories.
One, carbon compound resistors that are made of carbon dust glue or graphite. These resistors are used for low powers.
Two, metal film resistors made of adhesive metals are conductive. These resistors are used at very low powers.
3. Wire resistors, which are the same resistors that are used in the heatsink and are used in high power.
Four, surface mounting resistors that are made using thin layer mounting technology on the surface and are used for high precision and frequency. There are different types of fixed or variable resistors with different manufacturing methods for each of them. These resistors have their own characteristics and advantages and disadvantages. In the following, we will examine the most commonly used and common types of resistors. Carbon compound resistors.
Carbon resistances are the most widely used and cheapest types of composite resistances. These resistors are widely used in electronic and electrical circuits. The internal element of these resistors consists of carbon powder or graphite, like the tip of a pencil. Also, in their composition, non-conductive ceramic powder, clay, is also used to stick the carbon round.
The ratio of carbon to ceramic, conductor to insulator, indicates the amount of resistance. The higher the carbon content, the lower the resistance. Finally, this mixture is formed into a cylinder. The two ends of the resistor are connected to two cap-shaped conductive pieces with a base, which form the base of the piece. With these bases, the part can be soldered on the board. Finally, it covers the insulation and resistance coating, and then color codes are inserted on it.
Carbon resistors are used for low to medium powers. This type of resistance has a low inductance value. As such, this resistor is very suitable for high-frequency applications. But one of the weak points of carbon compound resistors is sound and instability at high temperature. For this reason, these resistors are used less in circuits that require high sensitivity and accuracy. The names of carbon composite resistors are written with the prefix CR, for example, CR 10 kΩ. These types of resistors are produced in the same types as E6, 20% tolerance or accuracy, E12, 10% tolerance, and E24, 5% tolerance. Their tolerance is from 0.25 watt to 0.5 watt.
Two. Metal film resistance. Compared to carbon film resistors, metal film resistors have higher temperature stability and lower noise. Also, these types of resistors are more suitable for high-frequency or radio frequency applications. Compared to metal film resistors, metal oxide resistors have higher oscillating current and better temperature tolerance.
Thick film resistors are made by placing a very thick conductive paste of ceramic and metal on a substrate of ceramic and aluminum oxide. This type of resistance is called cermet. Cermet resistors have the same characteristics as metal film resistors. In general, these types of resistors are used in the construction of chip resistors and multi-resistor networks implemented on the printed circuit board, PCB, and high-frequency resistors.
These types of resistors have good thermal stability and low noise. The ability to withstand high voltage in metal film resistors is high, but the ability to withstand impulse current is low.
Metal film resistors are named with the prefix MFR. E.g. MFR 100 COM and CF prefix is used for carbon types. Metal film resistors are made in colors E24, 5% and 2% tolerance, E96, 1% tolerance, and E192, with 0.5%, 0.25% and 0.1% tolerance. The tolerable power of this type of resistors is from 0.05 watt to 0.5 watt. In general, film resistors and especially metal film resistors are used in low consumption applications.
Three. Wire resistors. As the name suggests, the electrical resistance of a coil is created by winding long resistance wires around a core, which is usually a ceramic or plastic coating on the wires wrapped around the core. They pull so that the wires inside are not damaged. Brick resistance is also one of the types of fixed resistance that is placed inside the ceramic cover to withstand high powers and is filled with a special type of insulation under these ceramic covers. These resistors are available in the market from 1 watt to dozens of watts.
The important thing about brick resistors is that they may get very hot during operation, and a suitable place for their installation should be considered in the circuit design. Since the wire used in the coil resistors is coiled, the property of self-conductivity is created. In this way, in addition to resistance, there is also inductance. This inductance causes phase shift, especially in larger resistances, in AC circuits and at high frequencies. Therefore, the total impedance, Z, is the sum of the apparent DC resistance and the series inductance. Impedance, Z, is the combination of the effects of resistance, R, and inductance, X, in series with it in an AC circuit.
Wire resistances have different values, from 100 ohms to 100 kilo ohms, due to flexibility in the thickness of the metal wire used and the number of possible turns of the insulation. Also, these types of resistors have a very small error, and for this reason, they are very suitable for measuring circuits and using them in the Wheatstone bridge. Coil resistors can withstand much higher electrical currents than other resistors.
Wire-wound resistances are indicated by the prefix WH or W. For example, WH 10 ohms, and are available in two types of aluminum coating, with tolerance 1%, 2%, 5% and 10%, and glass glaze, 1%, 2% and 5%.
Surface resistor or SMD. Another type of resistors that are soldered onto electronic circuits are surface mount resistors or SMD resistors. This type of resistor is shown on the PCB with black color and several numbers in the middle and silver color, soldered part, on both sides.
These resistors are rectangular in shape and are also called chip resistors. The resistors are made of metal and can be printed on the board. The design of this resistor can be done using ceramic or aluminum materials. The resistance can be calculated based on the thickness, length and materials used. These resistors are enclosed using a protective cover with successive layers. Protective coating layers prevent mechanical damage but do not stop the penetration of moisture and other contaminants.
Another type of resistors that are soldered onto electronic circuits are surface mount resistors or SMD resistors. This type of resistor is shown on the PCB with black color and several numbers in the middle and silver color, soldered part, on both sides. Types of variable resistance.
Variable resistors are resistors whose value can be changed in the circuit. And unlike fixed resistors, they have discrete values. The value of these resistors can be any number. Variable resistors are divided into two categories: independent resistors and dependent resistors.
Independent resistors.
Independent resistors are a type of resistor that does not depend on environmental variables such as temperature and light, and their value can be adjusted manually according to the circuit's needs. In this way, with the help of a small lever attached to their body, a specific resistance value can be selected from the available range. These types of resistors are divided into two categories.
One, potentiometer.
The potentiometer has three legs, two of which are fixed on the sides. These two bases are connected to a resistance element whose value is equal to the nominal value of the resistance. The middle leg is also connected to a movable axis that moves on the resistance element and changes the resistance between the middle leg and the two legs on the sides. A potentiometer is used to reach the desired potential.
Two, resistor. A resistor has a resistive element, a moving contact and a fixed contact, which are used in electrical circuits to change the current, achieve the desired current. Dependent resistors.
Dependent resistances are types of resistances that depend on environmental variables such as temperature, humidity, light, magnetic field and voltage. Dependent resistances have different types according to these variables.
One voltage dependent resistance, Resistor. 2 thermal resistance, Thermistor. 3 light dependent resistance, LDR. 4 magnetic field dependent resistance, MDR. 5 humidity sensitive resistor. Resistor, VDR.
VDR resistance, short for voltage-dependent resistor. The value of this resistance depends on the voltage, and the value of the resistance decreases as the voltage increases, photorelationship. For this purpose, it can be used to keep the voltage constant at one point of the circuit.
LDR resistance.
LDR resistor, abbreviation, light-dependent resistor. The value of this resistance changes with the intensity of light radiation to it. The higher the light intensity, the lower its resistance. Like a photocell.
Temperature-dependent resistor, Thermistor.
The amount of heat-dependent resistances or thermistor depends on its temperature and are divided into 2 categories based on the positive or negative thermal coefficient. PTC, which has an effective and direct relationship with temperature, and NTC, which has an inverse relationship with temperature.
Thermistor with positive thermal coefficient, PTC.
PTC, thermistor or thermal resistance is made of polycrystalline ceramic material with high positive thermal coefficient. In temperature measurement with PTC or positive temperature coefficient thermistor, electrical resistance increases with increasing temperature and decreases with decreasing temperature. That is, the temperature is obtained by measuring the resistance of the thermistor. Metals are used as PTC elements, but their electrical resistance is low. Therefore, in order to reveal changes in electrical resistance, the size of the metal resistance must be relatively large. For this reason, by creating resistance in the form of a coil, its length increases and it creates a lot of resistance.
B. Thermistor with negative thermal coefficient, NTC.
Resistor with negative temperature coefficient or NTC, abbreviation of negative temperature coefficient, is one of the electronic components of the resistance family, which decreases with increasing temperature and increases with decreasing temperature. These resistors are used in protective circuits etc. in order to regulate the load current during overheating. The value of NTC resistance is linear in the specified range in degrees Celsius and starts to become nonlinear with increasing temperature. In smartphones, the function of NTC is to report the battery temperature to the phone. During charging, if the battery temperature exceeds the allowed limit, the phone will immediately issue an order to stop the charging operation by reducing the NTC value.
Magnetic resistance or MDR.
As a result of applying a magnetic field to these resistors, their value changes. These resistors are also called MDR. This word is derived from the first letters of the words dependent resistor magnetic to the resistance point of the magnetic field. The remarkable thing about these resistors is that because in the construction of these resistors, semiconductors with the thermal coefficient of temperature are used, so if it increases, the value of these resistors also decreases.
5. Humidity sensitive resistor, HSR.
Humidity-sensitive resistor are sensors that change the resistance of the sensor when the humidity level of the environment changes. Humidity-sensitive resistor is made of materials that have low resistance. Generally, the relationship between resistance and humidity is inverse.
When the top layer absorbs water, the resistance between the electrodes changes. These sensors are cheap and relatively small in size. They are often used in industrial, domestic or residential and commercial humidity measurement. To support me, subscribe to my channel. Like my videos. Press the bell button for notifications. Subscribe to my channel for new videos. Share my videos. Write me a comment. Thank you.